Okay, we're looking at geometry, and this is the first standard in the geometry unit. This has to do with scale drawings, and the reason it's in geometry is because it's geometric figures, it's shapes. So let's go ahead and start here. A scale model. A scale model is just if you took a big building or car or plane or a map and you shrunk it down, that's a scale model because you can't draw an actual building size building. You have to draw a scale model of the building. So this question is telling you about the scale model, and then it says if the scale is 1 inch equals 15 feet, what are the dimensions of the actual building, the real building in real life? So I have a building, and again, anytime I have geometry type things, I usually draw them out. So there's my building. Pretty simple, it's a rectangle. So it says 8 inches by 12 inches. So this probably is 8 inches down here, and this is 12 inches up here because buildings are usually tall. So the scale is, again, just a proportion. It's just what we've been doing with proportions. So 1 inch equals 15 feet. You always put the scale, the little one on top, and the actual size on bottom. So 15 feet. So this is the scale, and this is in real life. Okay. So it wants to know what are the real dimensions. So since there's 2 dimensions, we have to do the proportion 2 times. So if the scale model is 12 inches tall, I don't know how many feet it is. So again, I'm going to cross multiply. Well, 1 times x is 1x, so that's nice and simple. So it's just x. And 12 times 15, I come to my calculator again. 12 times 15 equals 180. So this is 180 equals x. So in real life, this building is 180 feet tall. Okay, so 180. And then here, 8. I can set that up again, but because of space, I'm going to just go ahead and erase because this is exactly the same equation. I'm just doing it for 8 inches this time. Okay, again, 1 times x is 1x, and 8 times 15. Clear. Remember, this CE is the clear button. So 15 times 8 equals 120. So if I come over here, this is 120 feet wide. And it makes sense because this is a smaller number than this, so it makes sense. The following 2 triangles are similar. Similar just means this is, for example, the actual one, and then I shrunk it down, and this is my scale. Okay, similar just means they're exactly the same shape. It's just like I took the corner and shrunk it down, or I took this corner and I made this one bigger. So if they're similar, then I can find x. So that means if I put the small one on top, I could put 1/2 over 1 because these 2 sides go together, or 1.5 over 3, or 3/4 over x because see, these match. And I know it sounds silly because we know that these are obviously the same length, and that says 1, that says 3. You have to not pay attention to that because the picture is not always drawn to scale. It's not always drawn correctly. So they just made a triangle and put numbers here. So don't get confused when this is 3 and this is 1, but they look the same. So if I can put 1/2 over 1 and 1.5 over 3 and 3/4 over x. So I can say 3/4 over x. See how I made that line nice and big? So I knew that that's my fraction. Equals, and then I just pick one of these other ones. So I can say 1/2 over 1, for example. So 1/2, right? See, here's the small one. This is the small one. And then the big one, 1. And then I just cross multiply again. Well, I picked this one because 1 is easy to multiply. Okay. So I've got 1 times 3/4 is 3/4. It's the same. Equals 1/2 x. 1/2 x. Okay. So I can solve this. I know it looks tricky, but just remember your rules. This is multiplication. I'm multiplying 1/2 times x, so I need to divide by 1/2. 1/2. Those go away. And then divide by 1/2. Well, let's come over here and rewrite that up. 3/4 divided by 1/2. So we rewrite 3/4, put a dot, and then we flip 2/1. 3 times 2 is 6. 4 times 1 is 4. 6/4. Technically, this is right, but that's not going to be one of your options because it's not simplified. So I can divide and turn that into 3/2, and I can also say that's 1 1/2. That is your answer. 1 1/2 goes right there. And if you'll notice, this is 1 and this is half of 1. This is 3 and 1 1/2 is half of 3. This is 3/4 and 3/4 is half of 1 1/2. So it makes sense. This is half the size of this. Find the area of the smaller similar rectangle if the area of the larger rectangle is 40 square feet. So if the area here is 40, and look what I'm doing. I'm writing on it. I need to label what I know. This is 40. So I also know that in order to find the area, I have to multiply 4 times whatever this is. 4x, 4 times x equals 40. So I know that my x here has to be 10 because I divided 40 by 4 and I got 10. So this x here is now 10. This is 10. Okay, so this is similar. Okay, so that means if 4 turns into 2, 10 also turns into, and we can do this math in our head, is 5 because 2 is half of 4 and 5 is half of 10. But if we couldn't remember, we would just put, let's see, 2/4, and then we know this is 10, so this would be 10. And I would say, oh, I don't know what that is. So 2 times 10 is 20. And then 4 times x is 4x. And I would divide by 4, and I would see that it was 5. Okay. So again, that is what that side is. That's great. So you see, I had to figure out what that side was. Then I used that information to figure out what that side was. So now I have to still find the area. So the area, again, 2 times 5. Is 10. So the area of this, 2 times 5 is 10. That is the area. Two similar signs have a scale factor of 5:3. If the larger sign is 40 feet tall, how tall is the small sign? So the two signs, there's two signs. Big sign and a little sign. And this one is 45 feet tall. So this side here is 45. And what I don't know is what this one is. I don't know. But I know the scale factor is 5:3. Okay. So 5/3. Okay. So this is the scale and this is real life. So I can say I don't know what I know this is 45 feet tall. I'm so sorry. I put my 45 on the wrong part. There we go. Because that's the bigger one. 45 goes with the bigger one. So my smaller one is where the 3 goes. So I multiply 3 times 45. 3 times 45. And then I divide by 5. And I get 27. So my other one is 27 feet tall.